In this video, we'll be looking at how to simplify compound fractions, which is what happens when you have a fraction inside of your numerator or denominator. So a fraction inside of a fraction, essentially. Your first step to simplify these is to find the least common denominator of all of the individual fractions that you have in both the numerator and denominator of the larger fraction. Once you identify the LCD, you're going to multiply every single term or fraction, if it is a fraction, by the LCD. And then your last step will be to start combining like terms and canceling out anything, common factors that you might have at the end. So here you can see that we have one large fraction, and then within this large fraction, in the numerator there's a smaller fraction. In fact, there are two of them. And in the denominator there are also two smaller fractions. So our first step is to find the LCD of all of these smaller fractions within the larger one. The best way to identify the LCD is just go through them one at a time. So the first fraction has a denominator of y squared in it. So the exponent does matter for these as well. Since I have the second power, I need to include that for the LCD. The next fraction I'm looking at has an x squared. So every time you see something new, just multiply those pieces together. The next one, now I'm looking at the denominator of the larger fraction. So in the bottom left, I have y squared, but I've already identified that one. It has the same exponent, so this one's okay. And then I have x squared getting repeated. So again, I already have x taken care of, and specifically it's x to the second power. So I don't need to adjust my exponent here either. So now that I know what the LCD is, we're going to take this and multiply it by each of these four fractions one at a time. If you ever need to write those, the work for that off to the side, that's fine. I'm just going to be showing you that when I multiply x squared, y squared times the first fraction, some of it will cancel and some of it will not. Technically, I'm multiplying the LCD by everything on top and bottom. I've just written it out for each individual fraction to make the canceling steps a little bit easier to see. This is not required, but it could help you to get the answer correct at the end. Now, the reason I'm multiplying it twice on top is because I have a fraction and then a plus or minus sign. So this is a new term or a new fraction, and then there was another one on the top. In the denominator, the same thing happens. I have a fraction, and then it gets separated by a plus or minus sign. So this is a new term or new fraction. And then there's a second one in the denominator as well. So altogether, I'm going to be doing this operation 4 times. Now, when I multiply the first, the top left fraction, I can see that I have a y squared, and then there's a y squared in the bottom of the fraction. So those will cancel. For the next fraction, the x squared will cancel the x squared out. In the bottom left, the y squareds will cancel. And in the bottom right, the x squareds will cancel. So now we'll focus on what is left after canceling things out. In the top left, I had x squared, and there's still an x left. So when you multiply those together, you end up with x cubed. And then I have a y times another y squared, and do keep in mind the sign that you have in the middle. So this is a minus y times y squared. So it's going to end up being negative y cubed. And then in the bottom left, the y squareds cancel. So now I have x squared times 1. And in the bottom right, after the x squareds cancel, I have negative 1 times y squared. So we've dealt with the compound fraction situation at this point, but now we need to continue simplifying using our normal procedures of factoring, for example. So here on the top, I have what we call a difference of cubes. So this would break down to be x, y, times x squared, xy, y squared. And then remember this sum or difference of cubes, this is where we use the acronym SOAP. So the same sign, the opposite sign, and then always a positive. In the bottom, this factoring technique is a little bit easier. This is just the difference of squares instead of the difference of cubes. So this one will just be x plus y times x minus y. Now that we've done the factoring on that, we can see that there are some common factors on the numerator and denominator. So I can cancel those out and then focus on what's left. So here the final answer would just be the x squared plus xy plus y squared, all divided by x plus y. This cannot be factored or broken down anymore, so it's okay to just leave it exactly as that. So now here is a second example. Again, we have a larger fraction, and then within it, this one is just a single term. It's not actually a fraction, but we're subtracting a fraction. So we call it a compound fraction because I do have this piece inside of the larger fraction. It's also happening in the bottom. So we do have a compound fraction here. For identifying the LCD, we can ignore the ones that aren't fractions. The denominator of this is 1, so it's not going to affect anything I'm doing right now. But for this fraction, I have a denominator of x plus 5. And then in the denominator of the larger fraction, we have a denominator of x minus 3. So we're just focusing on the individual smaller fractions for identifying our LCD, and then we need to multiply this by everything. Even though the 2's aren't fractions, we do still need to multiply them by the x plus 5 and the x minus 3. In a situation like this, it can even be handy to go ahead and FOIL out the x plus 5 and the x minus 3, because when I'm multiplying it by the 2, that way I can just go straight into distributing it through. So if I FOIL this out, I know that this is also the same as x squared, and then the outside and the inside product combined would be plus 2x, and the last product would be negative 15. So whether I use the x plus 5, x minus 3, or the x squared plus 2x minus 15, they're equivalent. I do need to multiply that by all 4 of my terms, which are again separated by these plus or minus symbols in the numerator and denominator. So here I've just shown that I'm going to be multiplying my x plus 5 times x minus 3, which is the same as x squared plus 2x minus 15, by the 2's on the top and bottom, and over here on the fractions. And to repeat, the reason I've gone ahead and already distributed this part here is because I knew nothing would cancel when I multiplied it by the 2. So to save time, I instead wanted to be able to see what would happen when I distributed the 2 through. But over here, I left it in the factored form because I'm expecting some of the terms to cancel out, and then that will be easier to focus on what's left. So for what cancels, I'm only going to see canceling on the fraction ones. Now I see that the x plus 5 will cancel the x plus 5, and in the denominator, this x minus 3 will cancel the x minus 3 when I multiply it out. For the parts that don't cancel, don't forget to do 2 times all 3 of these terms. We are distributing this out. So in my numerator, I'm going to have 2x squared plus 4x, and then minus 30. So that all comes from this product of 2 times the trinomial here. Now we need to focus on this part on the right-hand side of the numerator. So I cancel the x plus 5s, which leaves me with negative 13 times x minus 3. Again, it's helpful to just go ahead and distribute this now to save some time and space. So negative 13 times x, but make sure you're also doing negative 13 times negative 3. Because of the parentheses around the x minus 3, we have to multiply this negative 13 through both terms inside. Now we'll do the same thing in the denominator. So down here I have 2 times, and it's that same trinomial, so it actually should come out the exact same way. I should have 2 times x squared, 2 times 2x, and 2 times negative 15. Since both my numerator and denominator had a positive 2, I was expecting to get the same answer for the first 3 terms multiplied out. So that's a good way to check your work as you go along. Now I need to focus on the bottom right part of the fraction. So the x minus 3 is canceled, but I still have a positive 3 times x and positive 3 times 5. Again, we must distribute because of the parentheses being used here. So positive 3 times x and positive 3 times 5. Don't try to cancel anything from the numerator and denominator yet. Instead, just focus on the numerator and denominator separately. See what kind of combining like terms you can perform. So I only have one x squared term in the numerator. For x to the first power, I have positive 4 and negative 13. So this will be a negative 9. And then for the constants, we have 39 and negative 30. So this will be plus 9. Now we'll combine like terms in the denominator as well. Again, there's only one x squared term, so that just stays as is. I have 4x and 3x. These are like terms, so I can combine them to get 7x. And then we have negative 30 and positive 15, which is negative 15. Now don't forget to try to factor. This may not look like it, but it is actually a pair of factorable trinomials. So in the numerator, if I'm making my two binomials, it has to be 2x and x. And then I'm going to use the numbers 3 and 3 to equal 9. We want the product to equal a positive number, but for them to add up to a negative, so they must both be negatives. You can check this factoring to make sure it works, but I'm going to trust it here. And then in the bottom, same thing. This is a trinomial, but it's the more difficult case where we have to guess and check. So I'm going to have 2x times x. That will equal 2x squared. Then I need numbers that multiply to 15. So I'm going to use 5 and 3. And for the signs, I want to have a minus and a plus, because then I can see that the outside product is positive 10x. The inside is negative 3x. 10 minus 3 adds up to 7. That's how I know that this works. And with that factoring done, I actually do have some factors that will cancel. So with the matching 2x minus 3's on top and bottom, now my final answer is just the x minus 3 over x plus 5. So that's it for our examples on how to simplify compound fractions. It's a lot of the same work we've been doing once you get down to this point, combining like terms and factoring, but dealing with the fractions inside of fractions. That's the focus of this lesson.